Okay, so now today, by the way, tomorrow I'm canceling the class. Okay, I have a meeting with somebody. That meeting is from 6 to 8 or something, but I have to drive around 10 miles, and probably there may be at least some drinks or something, and I don't want to come back and teach after having drinks. So I think let us cancel tomorrow, and we'll meet again on Thursday. So I'm canceling tomorrow's class. Okay. So I already canceled it. So just remember there's no class tomorrow. Now, there is a lot of things that we're going to learn now. VPC is one major important topic. We're going to learn that today, and probably by next class we'll be finishing it. Then we have to get into one important topic is actually relational databases. Amazon is providing databases as a service. Very, very important topic. We will be looking at load balancers, how you can do load balancers. We'll be looking at auto scaling. Then the important topic is actually IAM, Identity and Access Management, how to create users, how to permission users, how to create groups and put them into users and groups, and how to establish federation between your company and Amazon, so that you don't have to create separate user accounts. If your company is having Active Directory, you all go to your company, you log in with the username and password. You can use that same username and password to connect to Amazon. That is called federation, or in some words, people say single sign-on. Then we will be learning all these different management tools for different things, monitoring, cloud formation for automation. This is where you do a lot of automation with the cloud formation. Just the click of a button, your VPC created, your instances created, your subnets created. You can do a lot of things with cloud formation. CloudTrail is complete logging and auditing of your site. We'll be looking at those things. We're looking at mobile device farm for mobile application, how you can use device farm to test your applications, web application, mobile apps and mobile web applications using iPhone and iPhone 7 and things like that. Very interesting topic on this device farm. So we'll be covering some important topics after this, but the core of the course is actually to understand EC2, and then getting all these things we need to learn storage. So there are a lot of interesting topics that we need to cover, but VPC is probably the core of it because everything comes under the VPC. So we're going to talk about that today. Okay. Okay, Minhas, what did you say? I didn't understand what you said on the typing message. I don't know. Okay. So VPC. VPC stands for Virtual Private Cloud. So what I want to do is I want to take some stuff here. So let's just go through and read these two things, couple of things, and it is very interesting. Now you need to start looking at these pictures and things like that. This is very important. So I'm going to explain certain things. You may not understand certain things now, but eventually by end of the class today or by next class you will get a clear understanding. So don't worry about it if you are getting it, but it is very, very important. I told you in Amazon cloud environment, you are learning this class as a architecting cloud infrastructure, where you will be learning server builds, how to build servers, how to build instances in, rather I would say, Linux and Windows instances, how to configure their volumes and storage and things like that. Then you will be learning about networking, and that is what this topic is. So a cloud administrator is all in all, he should know servers, he should know storage, he should know networking. So VPC is more about networking. How many of you in the class, if you know, just say yes, okay. How many of you are familiar with networking, subnets and VLANs and routings and things? Anybody know Cisco guys? Any Cisco networking guys or Juniper networking guys? Anybody in this class?
I had a certification long time ago. I don't think so.
Okay. Right. I see a couple of people know some networking. That's good. Even again, I myself is not a networking guru, but I think I have a good understanding of the networking that a cloud administrator need to know. So I think that is all we need to know. All right. So let's start with VPC overview. So a virtual private cloud, that is what a VPC stands for, is a virtual network. I told you it's a logical network. It's a virtual network that closely resembles a traditional network that you would operate in your own data center. So it is pretty much like a networking that you see in your data centers, where you create different subnets, different IPs, different IP ranges, routing, all routing tables, all that things will come into picture. So with Amazon's scalable infrastructure, or AWS, you can create a virtual private cloud. So once you create a virtual private cloud, then you can create your instances into that. Okay. So this picture is actually showing a virtual private cloud. Let me go here and look at something. We'll just read a little bit on here also. Amazon Virtual Private Cloud. So Amazon Virtual Private Cloud, or Amazon VPC, allows you to provision, that means allows you to create a logically isolated section of Amazon Web Services Cloud where you can launch AWS resources in a virtual network that you define. That means in that Amazon environment, in that region, remember, first thing I wanted to talk is a VPC is only within a region. You cannot extend a VPC between multiple regions, okay, not availability zones. A region will have multiple availability zones. Absolutely, a VPC can span between all that availability zones, but you cannot extend a VPC across multiple regions. So what this VPC will allow you is, it will allow you to logically isolate a section of the Amazon Web Services, a section or part of that Amazon's cloud infrastructure. You can just isolate and say, hey, this is my world. So in our environment, in my business environment, we have Virginia region. In this Virginia region, we have a VPC for our production servers. We have another VPC for our development servers. I could have done like this. I mean, we are doing like this. I could have had another way. Instead of doing this, I could have had two separate accounts, account 1 and account 2, and then in this account, in the Amazon region, I will create a VPC and I will say this is production. And in this account, another region, in the same region, I will create another VPC, which I can call it as development. This is also possible. There is no, so if you have a server here, and if you have servers here, there is no way these two servers can communicate to each other. So if you have a VPC, and if you have another VPC, And if they are in the same region, and you have an instance here, you have an instance here, these two instances cannot talk at all. They are completely isolated. So this is exactly what happens in real world. In Amazon's Virginia region, I'm just drawing Virginia region, there will be many or thousands of VPCs belongs to different companies. These are all VPCs belongs to different companies, small and big and things. And there will be servers inside these VPCs. But this belongs to Citibank, this belongs to Bank of America, this belongs to Johnson and Johnson, this belongs to Uber. No issues. They're all running in the same cloud. Maybe these VMs are all running on the same hypervisor. They're all running on the same server, but they cannot talk each other because they are all logically separated. Are you getting what I'm saying? So you are putting a logical separation of your resources from others, and that's what actually a VPC can do for you. Once you have
So
a
is this
VPC, you have to
is this
design it and you can create it. Okay?
question? So just one company have one VPC or something like that?
No, a company can have multiple VPCs depending on your needs. That is what I said. You know, we have one account and we have 3 VPCs there, one for production. So all the production instances are in one VPC. All
Right.
the UAT instances are in another VPC. And all the development servers are in another VPC.
So there is no trust relationship or something we can
No, no.
build? Or no.
No, there
No?
are, we'll look into that little later, but at this point, Kashif,
Okay, that's
just
fine. That's
keep
fine.
that in mind. They are completely separate. Okay?
Deepu, if two different VPCs overlap on a specific availability zone, can the instances inside those VPC communicate between each other?
No, there is absolutely no communication. They can have same IP addresses. So, for example, that's a good question actually. So I have a region, and in this region I have a VPC, and you have a VPC. You can have a server with the same IP address that I have. No issues. And they both may be running on the same Hyper-V server. This server will have the same IP address, this will have the same IP address, but no issues because they are in two different completely isolated networks. So this server can never talk to this server. So there is no issues of
Are you
IP
sharing a diagram?
Okay.
Cherry, I'm not seeing any screen changes. If you are sharing different diagram, maybe it's not visible.
I don't know. Can everybody see my screen?
Yes, we can.
Okay.
Yes.
See, VPC wizard only, but you are not on the another screen, right? On the
No.
blackboard kind of screen.
No.
No, okay. Right.
All right. Now I just took this document. Can you all see that?
Yeah.
Oh yeah.
So here is the second part. So once you have a VPC, you have complete control over your virtual networking environment. So once you have a VPC, you control everything there, including the IP addresses, the creation of the subnets, configuration of the route tables, network gateways. These are all terminologies that we're going to look now. All that things you manage. Once you have a VPC, you create the network, you define what is the IP addresses, you define what is the subnet, you define what the route tables, you define the network gateways, everything is done by you. Okay? All right. So I think if I talk all these things, it will make you guys a little confusing at this point. Let's not do that. Let's get on to this picture here. So this picture, if you look at very closely, I'm going to explain this picture here, okay? So just understand this and then we will see how to create this. At that point you will understand what it is. And then I will talk about the properties and limitations and all that things I will talk a little later. First of all, let me just try to get you a feel of this. So I think that is the best way to make you guys understand that. Otherwise, if I start talking all these things about VPC, it will go crazy. So, getting started here. Let me see here. Documentation. Okay. I think this is good one. We'll start from here. So if you look at this picture, I'm just explaining certain things on this picture and then we will talk about all other things. Okay. So this is actually, the picture is saying this is an Amazon region. Look at this outer ring. That is the Amazon region. So when you see that icon, that means it is the Amazon region. So it is saying the region. So the region can be Virginia, Oregon, Singapore or Mumbai or anything. So when you have what is there in the region? Inside the region, what is there?
Availability zones.
VPC?
Inside the
VPC,
region is availability zones. Okay, inside the region is where availability zones. So you can see these dotted lines here. And this is availability zone B. And this is availability zone A. Okay. So I will do one thing. I will probably, okay, so that's fine. We will do that. So there are two availability zones here in this region. There may be a couple more there, but they are only showing two availability zones here. And then they created something called as a VPC within that two availability zones. When a VPC is there, this is the icon. If you see that icon, that means it is a VPC. You can see there's a lock and all. That means there is some kind of a protection there. You can have some VPC level security there who can get into the VPC. So this is your world. But this is the region. The region can have many other VPCs, correct? There may be other VPCs there. You don't care about. You are just creating your world here, and that is what that lock is, and that is what a VPC. So this VPC span across two availability zones at this point. Within the VPC, you can create subnets. Subnet is nothing but a range of IP addresses. We'll talk about that also in detail a little later. So you can create subnets. Subnet is where you define your IP networks. So this is a subnet. And you know that when we create instances, you first select the VPC, then you select the subnet, and then you are building the instance, correct? So you see here this picture, there is an instance here. That instance is within a subnet. The subnet is within a VPC. The VPC is within an Amazon region, right? So this is the region, this is the VPC, and this is the subnet. And inside the subnet is your instance. Then there is a concept called Internet Gateway. Internet Gateway is actually a router that allows access to internet. So this is the internet here. If you want this instance to talk to the internet, You remember this instance is inside a VPC. It is inside a subnet, and this instance wants to talk to internet, let's say google.com, and we yesterday built that server and we were able to access google.com, we were able to access yahoo.com. So if your instance wants to talk to the internet, it has to come through a router. Every VPC will have a router. We'll talk about that. Is a software router, and through the router, through the internet gateway, that instance can access the gateway. So just imagine if you do not have a gateway, internet gateway, can any of your instances talk to outside world?
No.
No.
Okay, so if there is no internet gateway, then nobody can talk to outside world. That is one key important point. Another key important point is when you create a VPC, now a VPC can be drawn like this or it can be drawn like a square box like what is showing here. When you create a VPC, you also have to create an internet gateway. You create a internet gateway, I will call it as IGW, and then you attach that internet gateway to the VPC. That is the first thing you need to do. So you create a VPC and then you attach a internet gateway to the thing. So internet gateway is kind of a routing service provided by Amazon. The internet gateway has access to internet, but you have to create an internet gateway for your purpose and then you have to attach it. Now the question is, can I attach multiple internet gateways to a VPC? That is not possible. Your VPC can have only one internet gateway. You cannot have two internet gateways for a VPC. One VPC can have only one internet gateway. So once you have an internet gateway, then you can create an instance within a subnet, and then you can say, hey, you want to go to internet. Okay. But simply it won't go just by attaching, just by having an internet gateway attached to a VPC, your instance simply cannot go to internet. There is a lot of things you need to do in order for an instance to go out. So let me repeat this picture again. Don't worry about it. If you don't understand it, it is completely understandable to me. So don't worry about it. Just listen to what I'm talking. So as I talk little by little, you will slowly get it. Okay. So I'm going to repeat this whole thing once again. So this is a region. Let's say this is Virginia region. That is this outside circle. Inside the Virginia region, there are two availability zones. One is that and one is this. These are the two availability zones. Availability zone A and availability zone B. And you all know what an availability zone is. It is a physical data center within that region. So two availability zones are basically two separate buildings in Virginia which are connected using high-speed fiber optic connection with less than 1 millisecond latency. They are very high-speed connected network, but they are two separate buildings, and this is in a region, right? This is what it is. So this is AZ A and this is AZ B. So we have two availability zones. Then you can create something called as a VPC in a region. When you create a VPC, you can specify what are the availability zones that VPC can be part of it. We will see how to do that. So this VPC, you can see that the VPC is created. That is that logical thing. It is created. The VPC will have an IP Cider block. So there is something called as a Cider block. Cider block stands for it is called as a common internet naming standard. What is that? I forgot that. Cider block. Cider block stands for Cider notation. Cider classless internet domain. That is what it is means. We'll do a Google search quickly for Cider block. We'll talk about that. It is called as classless inter-domain routing. That is what a Cider block means. So there's a lot of interesting topics about Cider blocks. There are different IP ranges. So these are all the different Cider blocks you can create. Don't worry about all these things. This is all part of networking. We will see what it is.
Is something related to netting?
No, it has nothing to do with netting or anything. No.
Okay.
So let's talk. Netting will come here. Netting is a very, very important topic in Amazon. We will see netting, but let's not bring netting into this here. So Cider block, just do a Cider notation. What is Cider notation? It is every company will have a Cider block. Your company will have a IP address range. Okay. So we'll talk about that. Hold on. Let me just slowly get into this. Then only I can make you guys understand this. Otherwise, it takes a lot of time. That's why I'm trying to do this in a nice way. So there is a Cider block, just to understand for that now. A VPC, when you create a VPC, you have to specify an IP range for it. So once you define an IP range, so that VPC will have something called a Cider block, classless inter-domain routing. Okay. So in your company, most of your company, can anybody give me an IP address in your company? Any server's IP address? Anybody? Do you remember any IP address in your company's network? Anybody remember? Okay, so I'll put it this way. Okay. So Kashif has put something like 10.121. Okay. So let's say, there is a company or Citibank. Citibank has a office or data center in New York City. So this is their data center in New York City. In this data center, they create different subnets. That means separate different IP subnets. And within this IP subnet, this is done by the networking team. Normally, the subnets are also called as another name, VLANs, virtual LANs. Okay, VLANs, and they will call a name for every VLAN. VLAN 1, VLAN 2. Normally, they call it as VLAN 1, VLAN 2, like that. VLAN ID. That is what it is called, VLAN ID. So there may be many subnets depending on the need. How many IP addresses you need, you can create different subnets. But this Citibank's, this New York office will have a Cider notation, CIDR notation, classless internet domain routing. That determines what is the IP address range. So let me say it will be something like 172.75.0/16. That's the 16 means how many networks you can create out of it. Don't worry about this now. So this is the Cider block. Just imagine for the New York data center I'm talking about a real data center in New York City. Okay. Citibank will have an IP address range like this. This is a public IP address they get from internet and they are using. So this is like a class B IP address or something. They have it. Once they have this Cider block, they can create subnets based out of that. So this subnet will have an IP address called 172.75. It cannot change, okay? 2.x. Look at the third octet, 2. So normally they call it as VLAN 2. It can be any name, but normally I would call it as VLAN 2. And there is another subnet, 172.75.3.x, and this will be called as VLAN 3. There will be another subnet here, 172.75.8.x, and you call it as VLAN 8, depending on that last of that. My question is, if the Cider block is this, can a network administrator in New York City data center, can he create an IP range like 172.54.3.x? Is this possible? This is not possible, because your Cider block has a definition. You cannot change this thing inside here. So your entire networks has to have these two start. Your IP addresses should start with that. So the Cider block determines what your IP addressing is going to be. Okay. Now you can have multiple Cider blocks, but normally companies will have only one Cider block per data centers. You can have multiple Cider blocks, but typically this is the case. Okay. So if Citibank has another data center in Boston, the Boston will have a Cider block. It will be probably 172.50.0.0/16. So here you can create subnets. What will be the subnets IP addresses? What will be the, can anybody give me the IP address of a subnet? 172.50.10.x is a good an example, right? It is possible. 2.x is possible, 3.x is possible, but it has to be 172.50. Okay. So that is within that data center.
I
So
mean,
that
is there a reason why it has to match those first two numbers in the IP address?
So when you do networking, you know, when you have this IP version 4 IP addressing, you know, there is something called as a network address and a host address. This is all subnetting. I'm not really getting into that, but when you take it, so you have to go and read and understand a little bit more about IP addressing and all, how it is. So in IP addressing, actually there is a network ID and a host ID kind of concept. So when you have a /16, actually you can have up to around 65,000. I don't know the exact 65,200 and something networks you can create, like that subnets you can create to the power of 16. Yes, it is actually 2 to the power of 16. That is what it is. So if you do not 2 to the power of 16, that is not correct actually. Okay? It is not correct. If you put a /24, so normally people put it as like, you know, 0-24. Subnets are created with /24. You can create with different. I'll show you that details now in a minute, how to do that. So when you create a /24 subnet, how many IP addresses you can create in this subnet? You can create up to 254. Okay.
254.
254. So you can put 254 computers in this network. If you want to put one more, you cannot do that. That is the maximum number you can put with a /24. Your Cider block is /16. That means you can get up to 65,000. I think there is a calculator here that will probably show you that number. Let me go there. I think I was trying to find out that. So here you can see the mask. If you put the /24, you can create up to, see, host per subnet. Okay, how many, you know, this is subnet. how many hosts or how many IP addresses you can create within that network. The /24 means you can create 254. If you put /25, then you can create up to 126 IP addresses. If you put /27, you can create only 30. If you put a /29, then you can create only 6 IP addresses. So if you create a subnet, with 172.75.3.0/29, you can only create in that subnet, you can only create 6 IP addresses. If you want to create more, the number should go down. So if it is 24, then you can create 254. You getting what I'm saying? That's the way you need to go. Okay. So I think that is clearly explained here in this diagram. Don't worry about these things. Okay, whatever I'm talking here. So you can see here. So here is the thing, 2 to the power of 16. That you're right, Mahesh. You said. So 2 to the power of 16 means you can create up to 65,536 addresses you can create. Okay. So that many networks you can create like that. Now this 2 to the, don't do like that. So this is how they calculate that networking. Okay. So I'm not a network expert to tell you the exact rule how that is come, but you don't need to worry about it. We will find out how to do this. Okay. So there is actually, you can see that, the IP version 4, relative to class A, class B, class C, if you put a /24, 2 to the power of 24, here it is, somewhere here, you can see here 2 raised to 24, then you can have up to 256 minus 2 actually, because you cannot use .0 and 255.255.255. You cannot use the last 255 also. So you can only use 254 IP addresses actually. Okay. Anyway, don't worry about that right now. Let us just try to understand the VPC first. So let's go back to this picture now. So we will see this. Okay, don't worry about it. I will explain this in a little more better way. I just want to, first of all, I'm not getting that feel of how to put that. Some classes I get it, some classes it is difficult. So today I'm actually a little struggling here. I don't know why. But anyway, we'll see that.
So Deepu, one quick question. Is it true that we are running out of IPv4 IP addresses and now everybody is moving on to IPv6?
Now, IPv6 is used in the internet. Internet is running out of IP addresses. Your companies, I don't think any company will run out of IP addresses at this point. So everybody is using IP version 4. I don't think any company started using IP version 6. Maybe some companies are using, but IP version 6 is the new version 6. It is actually, it is.
I think only defense establishments use it.
What is that?
Defense establishments use IP version 6.
Ravi, I'm not understanding what.
All the defense companies actually use IP version 6 for some of their military use.
All companies? What companies?
Defense.
There's too much background noise.
Okay, Minhas, can you please mute Minhas? Okay, thanks. Yeah, go ahead, Ravi.
I think defense companies actually use.
Okay, defense companies, yeah. See, defense and all may have so many networks, you have to mute, you can mute, okay, there is a lot of noise coming from your side, thanks. Yeah, so if you have, so many IP addresses, then you may run out of IP addresses. So, IP version 4, IP addresses, it is 8 octets, right? When you say 255, 255, 255, it's actually 8 bits here, 8 bits here, 8 bits here, 8 bits here, right? So 32 bits That is what actually an IP version 4 is. So 2 raised to 32. That is the maximum number of IP address. 2 raised to 32 is how much? That is the number of IP addresses you can create using that one IP range. Okay. Mahesh, I just unmuted you. Shyam Sundar, I don't know. These are all Vijay, I just unmuted you. Elton, unmuted. Kader, unmuted. Okay, I think that's all. Everybody else is Shyam. You are not. I am not muted you. You're on phone. Okay, so 2 raised to 32 is what the maximum number of IP addresses you can use with the IP version 4, whereas IP version 6 is actually 2 raised to 64. 2 raised to 64 is a very, very huge number, and that is the new IP version 6. I have not used it, IP version 6, but all the Windows servers and Linux servers all do support now IP version 6. I know IP version 6 is used for internet-based computers. Now IoT is coming. I think when they designed IP addresses 2 raised to 32 long back, probably around 20, 30 years back, they never even thought they're going to utilize all these IP addresses, because 2 raised to 32 itself is a huge number. But now that what is happening is with IoT and all, everything, is having an IP address. Every phone is having IP addresses. Every devices, going forward in your house itself. So can you tell me how many IP addresses in your house you use? You may have 4 or 5 phones. You may have 2 or 3 computers. That is all you use today. Tomorrow, your fan, your gate, your cooking range, your coffee machine, everything is going to have an IP address, and they're all connected to internet. And it's already started, and that is what IoT is, Internet of Things. Your car will have an IP address. Everything will have an IP address. And you can manage everything through internet. You can manage everything through mobile applications. So IP addresses are going crazy. The need for IP addresses in internet world is going crazy. But that is not the case in a company. Even you take Bank of America or something like that, such a big company, they have so many data centers and all, they still can survive with 2 raised to 32. They don't need to go beyond that. But if you have complete internet-based things, you need to go for IP version 6. Okay, and I don't have any idea about IP version 6, so I think let's not get into that discussion right now. All right, so let me move on. So you need to define a Cider block when you create a VPC. So here you created a Cider block called 10.0.0.0/16. That means I can create 2 to the power of 16. I can create that many subnets, small subnets in this VPC. And inside that VPC, I create subnets. You can see that there is a /24. This is a subnet. You can create a subnet. So I can create like this 2 raised to 16 subnets I can create here if I want to. That itself is a huge number. So if you want, you can create a Cider VPC with /16. I think, big companies normally do it. You don't need to do that. You can do it even with a less number. You can do with /25 or something like that also you can do it, so that you can have less number of subnets. But you have to plan that ahead of time, because once you define a Cider block, then you cannot change that. When you design a VPC, you have to create a Cider block, and that cannot be changed. So you create the subnets inside that, and then you create instances, and you can see that the instance got an IP address. Can you look at that IP? Can anybody tell me can you read that IP address? Can anybody read that IP address for me?
10.0.0.6.
10.0.0.6. That means in this subnet, that is the IP address. So I have a subnet here. I'm just going to draw a new subnet here. I'm creating a new subnet here. and this subnet's subnet ID is 10.0.1.0/24. If I create an instance here, can anybody tell me what will be the IP address that instance will get? At least a range. What will be the IP address of that instance?
10.0.1.10.
It can be, it has to be 10.0.1. something.
1.2 also.
Yeah,
Starting with
1.2
2.
or 3 or 4 or something. Okay. But anyway, I think I was telling you 1 to 4 is reserved by Amazon, and we'll talk about those things later. So you will never get 1 to 4 for your instances. It is reserved by Amazon for certain purposes. So you will normally get IP addresses from 5 and above. Okay. So it can be like Kashif says 25, it can be 32, it can be 200, it can be 225, or it can be 254. So that instance can get any IP address there. Okay, so let's just keep.
I got a question here. It could be a silly question, but what does the number after the slash represent actually? Like we see there like 24 or 32.
That is the mask. That is the one that determines how many IPs you can create, or how many IP addresses you can create in that, or how many networks you can create. That number determines /24, and that is what I was showing you here.
The IP calculator.
Yeah, and the IP calculator I was showing here. So when you put that mask, that the bit, if you put 24, that means you can create up to 24 hosts per subnet. If you use a /25, then you can create only up to 25. Now, how that is all happens, I can talk about that, but I think if I get into that discussion, then it will be a little difficult. So, if you have an IP address, mask is, when you have a subnet mask, it is normally say 255 dot, so sorry, I may do that, 255.255.255.0. That is one subnet mask. Mask you can create. Sometimes there will be something called as 255.255.0.0. There is another subnet mask you can create, something called as 255.0.0.0. Now this is all 0.0, this is all. So you have to understand, first you need, if you don't know IP addressing, I would say go to Wikipedia, there are some good documents. You need to understand different classes of IP addresses, class A IP addresses, class B, class C, class D, class E and all. But you don't need to know all these things. At least you need to understand what is class A, class B and class C IP addresses. Okay. Class A starts from certain range. Class A will have this subnet mask. Class B will have this subnet mask. Class C will have this subnet mask. So when you say /24, it is actually this subnet mask. When you say /24, that means how many bits are here? 255 means 111111111 ones, correct? 1111111 ones. 1111111 ones. How many ones are there? 24. That is why I say /24. Okay? Okay. Now I'm not going to get into that. Then that itself is a networking topic, but I just understand /24. But I hope you getting what I'm talking about, right? So this is how it goes. I have to brush up to talk all these things. I'm not prepared to do that, but it is a very interesting topic. You really need to. That is called as subnetting. You just go and try to learn about subnetting. Okay, IP subnetting, that is what the actual term is. Try to understand what is subnetting. You will understand all these things, how the subnet mask works, things like that. So when you have this like a /24, so how many bits are left now here?
8 bits.
8 bits. So 2 raised to 8. How much is 2 raised to 8?
256.
256, correct? When you have 256, I told you, you cannot have, can you have an IP address like 172.25.3.0? Is there any IP address like this? Can you give an IP address like this to a computer?
No.
You cannot give a 0. Okay, so there is something called as broadcast and things like that. So I'm not going to get it. So you cannot use 0 and you cannot use 255. So how many are gone from the 256?
2.
2 are gone. So what is the balance?
254. 254.
That is why when I say, or when I was talking, when you have a /24, you can have up to 254 host. Host means a computer, 254 host or 254 IP addresses. Does that make sense?
Yes, it does. Thank you.
When I say /25, /25, how many zeros are there?
7.
So that means in this 8 octets, in this 8 bits, one more bit is going to be used as a network bit. Okay, so this whole thing is called as a network ID and the remaining is called as a host ID. So how many bits are left here? 7 bits.
7 bit.
So 2 raised to 7 is what? 128.
8.
128 again, you will lose the 0 and 255. That is why you can only use 126. So as it goes up, /24, /25, /26, /29, you can go like that. That is why the numbers reduced. Okay. So this is how the IP addresses work. I think you got some idea, right?
Yeah, I did. Thank you.
So I think we'll stop there. If we get into that, then we will get in. Then I have to go with the whole networking topic. But I think let's not do that. That is not the goal here. So there are calculators which can give you all these things. See, if you put a /30, then you can have only. I think that means only one. Two bits. 1 bit, 2 raised to 1. No, 2 raised to 2. 4. 4 minus 2. Okay, 2 bits are left. 2 raised to 2 is 4. 4 minus 2. You get 2. That's how you're getting that. Anyway, let's not worry about that. I'm coming back to this picture again. So you get IP addresses. And then there is something called as a routing table. You see this custom route table or main route table or something. The route table, it is actually every computer has a route table. Every network will have a route table, not computer. Every network will have, every subnet will have a route table. The route table actually determines or tell you how the traffic should go. So here, if you look at certain things, don't worry about again what I am talking, okay? If you understand it, understand, otherwise forget it. A routing table is an important factor in a VPC. Every subnet should have a route table. You cannot have 2 route tables, but every subnet should have a route table no matter what. So this subnet has a route table attached to it. You see here, there's a route table attached to it. And that route table will have an address, source and destination, destination target IP addresses. It says is 10.0.0.0/16 is saying it's local. So when this computer, this instance, wants to talk to another instance in this VPC, okay, listen to this. Okay, let me ask you another thing. How many subnets I can create I can create so many subnets here. So let's assume that there is a subnet here. And inside this subnet, there is an instance, and that instance has an IP address of 10.0. Okay, 10.0.5.85. That is the IP address of this instance. So this server or this instance wants to talk to this instance. So it will go and ask the route table, hey, you know what, I wanted to talk to somebody called 10.0.5. thing. So it will ask the route table, hey, do you know that route? So the route table is saying, okay, anything in 10.0. range is local. That means don't have to go outside, that is somewhere here. So you talk to this router and the router will solve. This router, you cannot see that it is a software router within the VPC. We will understand that in a minute. It will route that to here, and this instance can talk to that instance. But let us say this instance wants to talk to Google. This instance wants to talk to Google. Google's IP address is something like 95.92.3.54. I'm just making a number here, okay? This is the IP address of google.com. So this computer wants to talk to google.com. And it got the IP address. It knows this is the IP address. So it will go and ask the route table, hey, I want to go to 95.92. Where should I go? So it will see, is there any route defined for 95? Is there any route defined for 95 network here in the route table?
No.
No. So since it is not there, the routing table will say, see, I don't know where it is, but I can tell you how to go out of this network. You can go to 0.0. 0.0.0 is like a broadcast, or it's not broadcast, it is actually anywhere. So it will say, if you want to go anything other than this network, you go to IGW ID. See here, it is saying go to IGW. IGW is what? Internet gateway. So it is telling the instance, hey, you want to go anywhere other than this IP address, 10.0. network, you talk to IGW. You talk to IGW, that's all it says. I don't know anything about it, but you talk to IGW. When you talk to IGW, IGW knows, oh, okay, I know where to go this 95, it is in internet, it will take you there. Okay, you are probably not getting anything from there now. Let's not worry about that. Now let me get into another picture here. And we're going to look into this little more in a little more different way. So there is actually a scenario examples, I think. Yeah. So in okay. So let me go back here again. Okay, let's take this example now. If you look at this picture, what is the Cider block for this VPC?
172.
16.
Come on, guys.
Class C.
No, what is the, it is not classy or anything, it's clearly written there. What is the Cider block for that VPC? That is my question.
172.31.
172.31.
Okay, 172.31.0.0/16. That is the thing. You should not say 172.31. That full thing is the thing. That is the Cider block for this VPC. That means inside this VPC, you can create 65,000 subnets if you want to. But any instances you created, not 65,000 subnets, you can create up to 65,000 IP addresses. Any IP addresses can only have this range. See here, this instance, there is one instance here. What is the IP address of that instance? 172.31.0.5. I told you up to 4 you cannot use. So the first IP address is 5 here. Look at this subnet. So what is the subnet ID here? 172.31.0.0. Look at this subnet ID, 172.31.16.0./20. So when you have /20, how many IP addresses you can create? Or how many instances you can create there? 2 raised to 20 minus 2, correct? Are you
2,
guys
yes.
following me? Okay. So here there is an IP address. There is another IP address in this instance. So now you can see that both these subnets are attached to a route table, and that is called as a main route table. Every VPC when you create, there will be a route table. We will get into that, okay? There will be a route table, and that route table will have some entries on where to route and all. So the first route table says 172.31.0.0, that is a Cider block. It says if you are trying to talk to anybody in this range, it is local. So if this instance, the first instance here, 172.31.0.5, that is an IP address of a server here. If this server wants to talk to 172.31.16.5, it will ask the route table, hey, I want to talk to somebody called 172.31.16.5. It says, okay, it is local. You do it inside. You route it here. See, it will go like that and talk. If it wants to talk to outside, it says, if you want to talk anybody other than this IP range, use 0.0.0. That means use IGW ID. You use the IGW. See, the internet gateway is there. So in this scenario, there are two subnets. Okay. Listen to this. This is very, very important. And we will learn. Okay. Don't worry. I'm very sure that many of you are not understanding anything that I'm talking right now. You may be thinking I'm not getting it. Don't worry. I will make sure that you get it. Okay. Please believe me. I will make sure that all of you understand it by next class. Today, I don't think you will understand it, but forget about it. But just listen to what I'm saying. So these...
I have a doubt here.
Okay, hold on. Let me just finish it, okay? And then we'll address your question. So these two subnets are attached to a route table, and that route table has a route, two routes, and there is a IGW route. IGW route will take you where? If you have an IGW, what will it do? It will allow you to go to internet, correct? So since an IGW is there, I'm going to introduce a new term here now. I will call these two subnets as public subnets. If your subnet is attached to a route table and that route table is having an IGW, then you can call that subnet a public subnet. That means any instances in that subnet can get a public IP address, and then they can talk to outside world. And you know that every instance can get a private IP address and a public IP addresses. We build that is how we were connecting, right?
That's natting, right?
No, that is not natting. That is not natting. We'll get into natting. Okay, let's not bring natting. What is natting?
Network address translation.
Okay, what does that mean? What does that do?
It translates the private IP address to public, and vice versa.
Okay, so but here it is not exactly like that. Natting is actually it's a network address translation. You get one IP address and then it will translate into another IP address. Okay, it can be, yes, you are right. A public IP address can be translated to a private IP address. There is some natting happens here, but don't get into that. Let's not talk about that for now. Okay, so these subnets are attached to a route table, and that route table is having an IGW. So I will call these subnets as public subnets. Look at this subnet and look at this VPC. This is a VPC, a region. Let me ask you one question here. Now I want somebody to answer it. I think you will get it by seeing these pictures. That is the main goal of today. I want to make you guys familiarize with this picture, because remember, we have to get into this picture. We have to get into something like this. This is where I want to take you guys, so that you will understand all these things. This is exactly what we are doing here. If you really look into this, you can see that this is a VPC, correct? See here, this is a VPC. Inside the VPC, there are subnets, there are availability zones, things like that. If you look at this picture, that picture is not clear. If you look at this picture, you are understanding now, right? Look at this picture. Something you are getting familiar. Earlier you didn't understand anything, but now you are understanding. Can you tell me how many VPCs are here?
4.
Four. No, two. Two VPCs.
Okay.
Is it 5 or 2
Two.
or 3? Look at it slowly. Take your time and
2
look at this
VPCs.
picture.
2.
Two VPCs.
It's only 2.
VPCs. What are the Cider blocks for each of the VPCs?
24 and
That's
No,
10
don't
dot
run. Don't jump everywhere. How many Cider blocks are? Yeah, 10.0.0, that is for VPC 1 and VPC 2 is 172.16.0.0, correct?
yes.
Okay, let's talk about VPC 1. Let us talk about VPC 1. How many subnets are there in VPC 1?
Two subnets.
Okay, how many subnets are there in VPC 2?
Two subnets.
2 subnets. Great.
Yeah.
Does each of these VPC have a IGW?
Yes, it does.
Yeah.
Yes.
Two. Yeah, both have.
Okay. Can I attach 2 IGWs to a VPC?
No. No, you can only have one, I think.
Alright, so you're getting, and there are routing tables attached to each subnet or say one subnet. How many routing tables are there for VPC 1?
2.
Okay. And they are attached to each of the subnet.
One.
This routing table is attached to this subnet. This routing table is attached to this subnet. So we'll learn that. Okay, we will get in there. But now let's come to this picture. Take your time and answer it. Okay, I want that answer is what makes me feel that okay, you are getting something. Otherwise, we have to do this whole thing again next class. That's fine. I will repeat. I don't mind because this is a class that needs the most attention. And if you don't understand this, you cannot do anything in Amazon. Those who don't understand anything, don't worry. I will make sure you will understand these things when I start drawing some pictures. I will use a paintbrush and I will draw this nicely and we will design it. At that point, you will understand. Right now, I'm just telling something, okay? I'm just getting you with IP, Cider block and things. Don't worry about it. You don't need to know all that 2 raised to 36 and all. You don't have to worry about it. But look at this picture. How many regions are there?
One.
One region. How many VPCs are there in this region?
One only.
Okay. How many availability zones are here?
2.
Okay, what is the Cider block for this?
24.0.0.16.
Somebody say point. Don't use the word point, okay? We will not use the word point. 10.0 point is not a correct terminology. If you go for an interview and you say that, that's the end of your story. It is always you should say 10.0.0. So nobody says 10.0. No, don't say that, okay? Dot. Always. Okay, great. So we have 2 subnets, subnet 1 and subnet 2. What is the Cider block for subnet 1?
24.
10.0.0.24.
And Cider block for subnet 2 is
10.0.1.0/24.
okay. If that is the case, look at subnet 1 carefully. Look at subnet 1 carefully. There are 3 instances somebody built there. There are 3 instances somebody created there. And look at their IP addresses. Do you think that IP addresses make sense? Are they belongs to that same subnet?
Yes.
Yes.
How do you say they belongs to that same subnet?
Same Cider block. 10.0.0.
0.0
One network ID.
Correct.
Network.
So the first 3 octets will tell you 10.0.0, that is where you determine whether it is on the same subnet. Look at the second subnet and they have 3 instances there also. And their IP address is 10.0.1.5, 1.6 and that 1 came from the Cider block of the subnet. So if I have a subnet here, I can build one more subnet here, is it right? I can build another subnet here. Let's say this is my new subnet. And the Cider block for this subnet is 10.0.11.0/24. if this is the case, if I build an instance here, can anybody give me an IP address for that?
11.1, 11.5, 11.6.
No,
It will be
Yeah.
it will be
10.
10.0.11.56
11.5.
7 or 8 or something like that. Okay, great.
So Deepu, Cider block is associated to a VPC or a subnet?
No, Cider block, this is actually the Cider notation, and this is actually this is also, you can call it as a Cider, subnet Cider. This is the VPC Cider. The entire VPC, you're saying that is the thing. That means you cannot have any subnet other than this range. In the subnet also, you can say it's a subnet Cider block, that is the Cider ID, that is
Okay.
the thing. So you can call that also as a subnet. It's called as the subnet ID. That's the right word, subnet ID. But this is actually called as a subnet mask. Okay, Davinder, go ahead with your question.
So this subnet we're defining, they're private subnets, right? Not public.
That is what I am coming to. So my question is now, so we are all talking all these things. You are all right up to here. Are there any routing tables attached to this subnet?
No.
Yes.
Subnet.
only one main
Yes,
routing.
only one.
Only one.
Okay, what is the name of that routing table?
Main
Main
Local.
route table.
Local.
What is the
Local.
name of
Main-
that routing table?
Main route table.
Main route table.
Main route table. This route table has only one entry, which is local. Does it have an IGW?
No.
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 So do you think any of these instances will get a public IP address?
No.
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 Can any of these instances go to internet?
No. No. No.
So this is a completely isolated world. If you build a VPC like this, you will never be able to connect to these servers because there is no internet gateway. If there is an internet gateway, then only from your house, this is your house. From here, you can RDP or something like that. If you want to do it, you need the internet gateway. But there is no internet gateway. This is an isolated world. Correct?
Yes.
So we'll talk. So you may be wondering, if it is an isolated world, how do I connect? That all we will address later. But right now, I'm going to say that this is a private subnet. This is also a private subnet because there is no internet gateway. Private means it is within the VPC. Okay? Now,
So I'm thinking like, can a Cider block be associated to two different VPCs? Same Cider block.
yes, you can. But in future, if any time, but there are some concepts about you want to merge these companies. So this is a Cider block for Citibank. Okay. Now, Bank of America can also have the same Cider block, and they can create a VPC 10.0.0.16. Absolutely, they can. But in future, let's say Citibank and Bank of America got a merger, and if they want to combine these two things or something, it is not going to work because they are going to be duplicate IP addresses and conflicts and things like that. As long as you can keep them completely separate, you can have same Cider blocks, not issues. Because a VPC is your own isolated world. You are creating your world and you have your choice what IP address you want to use. Make sense?
Yes.
So answer to your question is, within a region, you can have same Cider block for two different VPCs. There is absolutely no problems. Okay?
So when the instances be able to communicate, like for example, like Bank of America instance would be able to communicate with Citibank instance because it's under the same Cider block.
No, you cannot.
Okay.
But if they are different, they can communicate. If certain things are done, there is a concept called peering. Once you do VPC peering and all, we will learn these things later. I don't want to. Yesterday, I told you about instances and security groups and all, and at the end, I told you, security groups are not attached to an instance. It is attached to a
Network
Network.
interface card.
So I don't want to get into that level. If I start talking that, you will not understand. So just don't jump here. Let us go slowly. But I will answer any questions you have. We'll make it clear. That is why I said this is a little complicated topic, but everybody will understand when I finish it. Believe me, I have taught so many classes. This is my class number 10. Everybody in the class understand, and this is what they said. They clearly understand, and they all really liked it. But you know, every class I teach in a different way, because every day, you know, I don't know. I don't follow books. I just talk with the students' answers and questions, and I go behind that to teach. Now you guys are asking a lot of questions. Probably that's why I'm not able to really focus and move forward, but that's fine. But end of the day, by tomorrow, you will understand this. So please believe me and focus on it, okay? But ask questions. Keep asking questions. All right. So Devinder having another question. Go ahead.
So can we assign public IP to the whole VPC?
No, you can assign IP addresses only to an instance. You never can then you never can put a public IP address to a VPC. But I know where you're going to. There is a concept called VPN, and when you have a VPN, that VPN router here will have a public IP address. Now, to your question is correct. That VPC will have a public IP address for your office to connect. We will get into that a little later, Devinder. Okay? Let's not jump into that right now. Everything is possible. Okay? So now I am going to another picture. I don't want anybody to tell anything right now, but I want everybody to spend the next 2 minutes focusing on this picture. Understand every icon, understand every notations there, and keep it in your mind, and then I'm going to ask questions to each one of you. I will pick and choose some people here. Though the class is a little big, I'm going to pick and choose certain people, and I'm going to ask. Now don't worry if you don't know. I'm not going to scold or I'm not going to say anything. If you don't know, you don't know. That's it. Okay? So you don't have to get tensed or anything. If you don't know, you say you don't know. That way I know. I'm going to pick some people and I want you to answer it. But spend some time and try to understand this picture. I'll give you 2 minutes, okay? Okay, look at again. Look at understand. I will be asking a lot of questions from this picture, okay?
Niku, what is elastic IP?
Elastic IP address is kind of a public IP address. Just for now, we understand. I think I showed you that elastic IP address thing in one of the classes. You can attach a public IP address or an elastic IP address, but we will talk about that in a different. Elastic IP address is a permanent public IP address. Remember, I told you we attached EIP. You can buy an IP address. You can buy a public IP address, correct?
Public IP address. Yeah, that's for completely you purchase it and then.
Correct. But it is a public IP address, so you can do that also. All right. So I think everybody is clear. So now I'm going to ask a question here. What is the Cider block here for the VPC?
24.
10.0.0.0. The Cider block is 10.0.0.0/16. That /16 is very important because /16 determines how many IP addresses you can create in that VPC. Total, including all the subnets, how many IP addresses you can create is determined with the help of Cider block. If you don't want 65,000 computers, if your company is not ever planning to build, if you're going to a small hedge fund company in New York City, or if you're going to a small car dealership in, or Devinder has he works for a company a decent sized company, but I don't think that company need 65,000 IP addresses, isn't it, Devinder? So when you design your VPC, I don't recommend you to put a /16. You don't have to put /16, you know. Unnecessary, you are wasting some resources at the back end. So you can probably build your VPC with a you know, 24 or something like that, or even a different, you know, subnet. You don't need that much big. Anyway, /16 is a very common Cider block to use. Okay, how many subnets here? 2 subnets. Right.
2 subnets.
One question, and I want an answer. How many public subnets are here? How many private subnets?
Only one public subnet and one private.
Okay, which one is private subnet?
Second one.
Subnet 2 is private.
Subnet 2.
Okay.
Subnet 2.
Subnet 2 is private. So can any instances in subnet 2, let's say 10.0.1.6, can that machine talk to internet?
No.
Okay. What is the name of the public subnet?
A custom route table.
Custom route table.
Public subnet.
Subnet 1.
Subnet 1. And the route table attached to, which route table is attached to that subnet?
Custom route table. Custom route table.
Custom route table. So you can create different names for subnet. You can create custom route tables also. So if I want to make subnet 2 public, what should I do?
You need to
Internet gateway.
I need to attach the internet gateway to that, right?
Gateway.
The same internet gateway. All right, so you are getting there. So this is how it is. Now there is another picture. And this picture has something little new also, which we haven't talked. But look at this picture carefully again. Look at this picture carefully. 2 minutes.
Virtual private gate.
Okay, so now I'm going to ask you a question here. Which is the public subnet here?
Subnet 1.
Subnet 1.
No, nothing.
Subnet 1.
Okay, who all saying subnet 1 is not a public subnet?
Kashif.
Okay. What about others? Is subnet 1 a public subnet? Everybody agree on that or not?
Yes. Yes.
Okay. Can you put yes, yes, everybody? Who all are saying yes, please type yes.
I'll say no actually.
Okay, now people are changing.
No.
Because there is like a virtual gateway instead of like internet gateway ID. I don't know.
First of all, look at that VPC or the whole picture. Do you see a IGW anywhere there?
No.
It's actually VGW.
Private gateway.
Do you see an IGW anywhere in this picture? An IGW looks like this. An IGW looks like this, and there is an internet picture is there. Or do you see any such picture in this picture?
No.
Okay, so there is no public subnet in this. Okay, but instead there is something. I know you all computer. It's called VGW. Now VGW is actually a VPN gateway, virtual private gateway, which will allow your network to communicate your company's network, your corporate network. So once you have a VPN established between your company and Amazon VPC from your company or from your house, you can straight away connect to any of these private IP addresses, 10.10.7 and all. Do you need internet to do that?
No, you don't need it.
So these instances can talk back to your office also. So in this picture, there is no public subnet. There is a route table, or this route table, this subnet, which is connected to VGW. So here they are saying, here in this picture, what it says is, hey, you guys want to talk to somebody like 10 dot something network, you can use this route, this router, internal router. That's a software router. You don't see anything there, but the Amazon has a built-in router inside that. But if you want to talk to anything outside of that, let's say you want to go to Google or you want to go to somewhere, route table says, I don't know whether you can go to 95 or anything. All I know is if you are going anything other than this network, use the VPN gateway. So they will all talk to the VPN gateway. And then the VPN gateway will tell, okay, I am attached to here into this company. Maybe you can come here and your company may have connection to internet. You can go like that to internet. You getting what I'm saying? But there is no direct route to internet. Okay? Let's not worry about that, these things now, but I think you got some different scenarios now, right? You see that, you know, a subnet, a VPC with private subnet and a VPN subnet, a VPC with a public and a private subnet, a VPC with only private subnet, a VPC with only public subnet, you know, you can see all these things.
So in that picture, the last picture we were looking at.
Yeah.
So the subnet 2 cannot go outside, right?
That's correct. Subnet 2 cannot go outside. That's right, because subnet 2 does not have a route. If you do not have a route, you don't know where to go. These guys are always going to talk to the route table attached to it and say, hey, you know what? This is the thing. They never can go outside.
All right. Thanks.
Okay. All right. So what's the time now? 10:38. Anyway, I think I'm going to give it a try here. We will do this one more time next class, but I just want to give you guys without I don't want to just leave it like that. And I'm going to, we will design a complete network tomorrow, but I'm going to design something right now here. Okay. And then we're going to make that now. I'll show you all that details later, but I'm going to design something now. So I went to a company, a small company in New York City, and they said, hey, you know what, Deepu, I wanted to move everything. I have 20 servers or 15 servers. We are paying a lot of money to hardware maintenance, you know, contracts and things like that are problems. You know, we want to move to cloud. Can you help us move to cloud? So I'm going to design a VPC for this company to move all their servers into internet. So I'm going to Virginia region. So this is Virginia region. In this Virginia region, I'm going to select 3 availability zones. Okay, so this is Virginia. So let's put this as a Virginia region. I'm creating it in Virginia region, and I'm creating a VPC now here that is going to cross across 3 availability zones. So this is one availability zone. Let's call it as AC-A or AC-AC. I would put it as, you know, US dash East dash 1A US dash east dash 1C and US dash east dash 1D. These are the three availability zones. Everybody following me so far? Now,
Yes.
I am creating a VPC here, and I'm going to say the VPC Cider block. I'm going to put a Cider block here. 20.20. Or let's say 20.0.0.0/60. That is my Cider block. Okay, so I defined a Cider block. Now I want to create subnets. You can create a subnet only in one availability zone. You cannot have a subnet like this. That's not possible. You cannot have a subnet like this. You cannot do that. You can only create a subnet within a availability zone. So I'm going to create a subnet here, and this subnet will have a subnet ID and a name, and let me call it as subnet 1, and I'm going to create a subnet ID here. Can anybody tell me? See, this is the first subnet I am creating. Can anybody tell me what will be the subnet ID I should use? 20.0.1
20.1.1.0.
Is that make sense? Does that make sense?
Yes.
Okay. I'm going to create one more subnet in another availability zone, and this one will have a Cider block. I'm going to call it as subnet 5. If I'm calling it a subnet 5, what do you think the subnet ID will be? 20.0.5.0/24. I can give any name, but I just use 5 because I'm going to use that 5 as the network ID. Okay. So I created two subnets. When you create a subnet, a VPC, there will be a VPC route table. By default, there will be a route table, and that route table is called what? Main route table, right? So there will be a main route table. That route table I'm not going to draw here. So there will be a route table here. That route table, let's call it as a main route table. The route table will have a destination and the target. Okay. And I'm going to put the route table entries here. The route table entry is going to say 20.0.0.0/16 is local, because that is the Cider block of your thing. I want to put another one called 0.0.0.0/0 IGW's ID. Do we have an IGW here?
No.
Okay. So I'm going to create an IGW here. I'm going to create an IGW here, and I'm going to attach that IGW to this VPC, and this is the IGW. Okay. Now I can say IGW's details here. IGW dash XXX. That's the ID of it. We'll see that later. And these two subnets are attached to this route table. Is these route tables public?
Yes.
I can create instances here.
Yes.
Yes.
Okay. So we will, this is today I'm just doing, this is not the way I want to teach it. We will do this whole thing again. But I'm going to design this much for now. And we're going to call this VPC as class 10 test. That is the name of this VPC. I'm going to call it as class 10 test, and we're going to do this. Okay. I'm going to wipe off all these route table and all, but this picture will remain. And then we're going to do this thing quickly. I know time is running out, but before that, I just want to show you how we do this. So let's go here. There is a lot of things. There is actually a start VPC wizard is there. When you do VPC wizard, now you may be getting a little bit. The first one, there are different types of VPCs you can create, and that is VC. A VPC with a single public subnet. You know what that means is, right? A VPC with one public subnet. What that means? That means there will be a VPC. In that VPC, there will be just one subnet, and that subnet will have a route table attached to it. And that route table will have a IGW. Then only it can go at the public subnet, right?
Right.
VPC with a public and private subnet. VPC with a public and private subnet means there will be two subnets, correct? One subnet will have a route table that has IGW, and one subnet will have a route table that does not have a IGW. And then we see VPC with public and private. So if you don't know any of these things, Amazon has created this wizard. You just click on this, it will create for you everything, okay? But that is not what we want to do. You can just use this and create, that any 10-year-old boy can do this. Create any of these things. That is not what we want. We want to create our own subnets, our own VPCs. So you will go here to the VPCs. There are different VPCs, and I'm going to create a new VPC now here. Okay, based on what?
Sorry, but what is the difference in using the wizard and creating it manually?
Using the wizard will only give you certain things. You don't have any customization. You want to create it like this. You designed a network. You want to do it like this. You want to pick your things. You want to create your things, and we'll see. So you are doing it. You're building a huge network, man. If you're going to move Bank of America or something like that, you need to create 50 plus subnets. You need to create multiple route tables and things like that. You won't be able to do that with a wizard. That's all.
Wizard, okay.
Wizard will
there are
just
not many
create,
options. Okay.
Yeah, wizard will create you something for one person to put 25 servers. That is not what we want. We want to design a big network, correct? So we're going to design this. So keep this picture in mind. So create a VPC. So you give it a name. I'm going to call it as class 10 dash test. That is the VPC name. Okay. Here it is. Create a tag with a key is equal to name and value set to spelling string. So this is your thing. Now you need to define a Cider block. What is our Cider block? 20.0.0.0/16. You can do /16/32 or something. So I'm going to use /16. Tenancy is default. Default is dedicated is I told you dedicated means you will have your own hardware and all. No, you want to do it in a public tenant. So you create default and you create a VPC. Okay, this is a very good thing. Can anybody look? I know, guys, we're going to cross a little more time today. Okay, bear with me. What is this means?
5 VPC only.
So that means by default, any account in Amazon can only have 5 VPCs.
Right.
If you want to have more than 5 VPCs, you can, but you need to put a support request to increase the limit so that they will increase it for you. but I don't want to do that. So I'm going to cancel this, and we have to go here and delete some of my VPCs. I'm deleting that VPC. Sometimes you won't be, you will know, we could not delete the following VPC because there are so many things in this VPC. Oh my God.
Deepu, can you just select whichever VPC you want and then create a VPC?
No. These are VPCs that I created manually. So basically I want to delete this VPC, guys. Hold on 1 second here. There is a network card from this VPC ID 442. So what I need to do is I have to go and delete everything. It is to go network card. There is a network card attached. So if anything is remaining there, it will not allow you to delete that. So I wanted to VPC ID 442. These are two network cards. Action, detach.
You might have. So if you have like subnets or instances associated to that VPC, you have to delete all that also before.
It's not allowing me to delete that.
First detach it.
No, it is used for some other directory service for me, and that is why I don't want to delete that. Okay. I can delete it still, detach it. No, it's not doing that. No, it won't do that. Okay, never mind. Let's go here.
Can we detach class 8 or something?
Yeah, I'm going to do that now. Hold on. When this is not going to work, VPC ID is EEA. Let me see, I can delete that. No, I think, Mahesh, there is only 5 you can create. That is also a limit. You can have a VPC with different Cider block. That's not a problem. I don't think that is a problem.
So basically deleting a VPC will delete all the instances also associated to it.
Oh yeah, I think it will delete all the subnets, everything within that. It should. But I know, Mahesh, now that you're saying, I just need to test it. Can I create 2 VPC with the same Cider block in one account? I'm not sure. But 2 accounts you can definitely create. I think I already have a 20.0 here. Probably that was the problem. Okay. But I think we got an error message also saying that. So this is 172.16.16. Let me see. I can delete this also. ENI. Okay. I don't think it will. These are all, I can delete it because I'm using some other services. That's the problem. I don't think it will work. It is done by certain things. Okay, I'll clean that out tomorrow because I'm using some other Active Directory services and all here. Directory services, that's all is using certain things. Anyway, let's go and do this for now. Tomorrow I'll clean it up everything. Okay. So we're going to create a VPC here for now. But I just want to see whether that 20 thing will possible just for testing. Okay, I'm just trying to do here 20.0.0.0 /16. I just want to see whether that is possible, because Mahesh said, and I think it may not be possible because you cannot have a, you can have. So here it is. You see here, there it is possible, Mahesh. Look here. I have two VPCs with the same Cider block here. You see that? So you can create same Cider block. That was not our problem. Our problem was we had reached the limit 5. You getting, Mahesh Patel? Mahesh was thinking that we already have a 20.0.0, so that is why we were getting the error message. You guys following me? So I am going to create a subnet. I am not going to create a thing. Let me create a 10.subnet here. It's a different name. I'm sure we can create this, but I'm going to put it as 10.0.0, and we're going to call it as class 10-test. That is our sub VPC name. So I'm creating a VPC. All right. So I created a VPC here. Now you can see all the VPCs. It's always better to filter your VPC like this. That is the VPC ID. So when you create a VPC, you create. So you created a VPC. Now there are so many things we need to learn about VPC. You can have some DNS things. This is the thing, DHCP option set, all these things, and there is a route table already created and attached to this VPC. This is the route table. Okay. I already filtered here. So if you go to the route tables, you can see that route table here. It is the default route table. And we are looking at the routes here. You remember the route table has the routes, correct?
Yes.
And this is the route. Are you familiar with this? That is our default local router, correct?
Yeah.
Okay. Subnets that are attached to this route table. This is the default route table. You can create your own route tables. We will learn all that little later. But right now, I would call this as a main VPC route table, because that is the route table that came with the VPC, right? Are there any subnets here? There is no subnets here. Route propagation, nothing is here. So we just created a route table. So what is the next thing we need to do? We created a VPC and the VPC has a route table.
I think we need to create a subnet.
We need to create subnets, correct? So go to subnets. Are there any subnets in this VPC? Because we selected this VPC, there is no subnet. So we are going to create a subnet here now. So I'm going to call it as subnet 1. Okay. And this is the VPC. Which VPC you want to select?
Class 10.
Class 10. And I told you a subnet can be created only within a
Availability zone.
availability zone. Let's look at our VPC. Which availability zone you want to create subnet 1?
1A.
1A. So let's go and select 1A. And we have to specify the Cider block. I told you, you can call it a Cider block here. So what is the Cider block going to be? 10 dot?
10.0 dot.
0.
1 dot. 1 dot.
1 dot
0.
0.
Slash
624.
Yes, as 16 we used everything. So it's a subnet you need only 254. If you want more, you can go that. So you create a subnet. So we created a subnet, and the default route table. Anytime you create a subnet in a VPC, the default route table for that main VPC route table will get attached to that subnet. Okay, and that is the route there. Let's look at our picture now. What is left now? We have to create one more subnet, correct?
Yes.
Okay, let's go and create one more subnet. So create subnet, and I'm going to call it as subnet 5 in the class 10 VPC. Which availability is on?
D. 1D.
And what should be the Cider block? 10.0.5.0/24. Perfect. So we created two subnets. Okay, this is subnet 5. Subnet 5 has a route table attached to it. You see that? It has route table, this is summary, this is the route table attached to it. And this is subnet 1, it has a route table attached to it. Now you can create instances if you want in that VPC, but we are missing something in this picture. What is missing?
IGW.
Because right now, actually I can create instances and all, but I cannot connect to that instance, correct? So I need to create IGW first. So you go to Internet Gateway, here, Internet Gateway, and you create an Internet Gateway, and let's call it as class 10 dash test dash IGW. I don't know whether we can put such a long name. I think there are some restrictions here. Let's see, class 10 dash thing I create. Okay. So I created an internet gateway. How many internet gateways you can create
One.
for a VPC?
One.
Okay. And I'm not seeing this here because I'm on this class 10 VPC, but I created a gateway, but I don't see it here. Why is that? So let's go to none and let's see whether the internet gateway that we created is here or not. Is it there?
You need to attach that internet gateway to that VPC, I think.
Correct. Once you create a internet gateway, you need to attach it to your VPC. Can you attach multiple gateways to one VPC? No, you can only have one.
No.
So this is the gateway we created. It is currently detached. So we're going to attach to VPC. You see that? Attach to VPC. Can I attach it to test VPC?
No.
I think I can because test VPC don't have it. So we have to attach it to our VPC, correct? Attach it. Now you go here and look at class 10 and you click on the internet gateway, you see the class 10 VPC. So now your IGW has an ID. You see here, IGW has a ID. Okay, so we now created all these things.
So will that now show up in the route table? If you go back and see if
okay, that is a good question. So now I just attach the IGW here, but that doesn't mean that if I create an instance here, that instance can go to thing because the route table that is attached to this is what route table?
Main route table.
Main route table. The main route table currently has only 10.0.0.0/16 local. This is the only path right now. So even if IGW attach to VPC, if I create an instance, does that instance can go to internet?
No.
No.
If it wants to go to internet, I have to add the route table, the IGW's details. I have to put 0.0.0.0 and I have to put the IGW's ID there. And we're going to do that now, okay? Let's go and do that. So let's go to route tables. This is our main route table. Does the main route table has this route of IGW?
No.
No. We're going to edit this, add another route. Now I'm going to say 0.0.0.0.0/0 and I will type here and I can see the IGW already there. 0.0. is IGW already it knows, so I just put the IGW here and I saved it. Now does the main VPC route table contains a public path?
Yes.
Okay.
Yes.
Now these route subnets, let's go and look at the subnets now. The subnet 5, if I build subnet 1, if I build an instance here, can this instance go to internet or not? We will tell you now. I'm going to subnet 1. The route table is there. Does it have an IGW?
Yes.
Yes.
Okay. I think we are good now for now. There is still a lot more to learn here, but I think you got some idea now. I see at least some people responding. So now we created a VPC. Let's go back to our EC2 instance. And let's
So subnet 5 is still a private subnet.
No, both are attached to the same
Oh,
route
both
table,
are attached.
right? We only have one route table, right?
Oh, okay, sorry, got it. Yeah.
You got it, right? We only have one route
One
table.
route table. Right.
If you look here, you can see that. You go and filter your thing. And if you look at the route table, there's only one route table. And if you click on that route table and look at the subnet association, you can see that the two subnets are attached. Subnet 1 and subnet 2.5 are attached.
Yeah, got it.
So they both are sharing the same route table at this point. So the picture is very much like this picture. This is the picture we are drawing now. Correct?
Yes.
So we'll see different combinations of this in later class. So what I'm going to do now is I want to create an instance and let's see whether this thing work or not, right? So launch an instance. I'm not going to anywhere. I'm going to go to our own image. We have our own AMI, correct? Do I need to go and pick a Amazon? No. This one, and we come here. Which VPC you select?
Cluster.
Custom.
And I want to put this instance here in this subnet. Okay? So which subnet I should select?
Subnet 1.
Subnet 1.
Okay.
Now, there is a setting, and I want to talk all these things, guys. You know, time is running really late, actually. Otherwise, I wanted to explain. So I will talk this later. Use subnet setting, disable, auto assign. You know, use subnet setting. It says disable. That means if I use this option, your instance will not get a public IP address. You following me? I'll explain this order, and then I'll finish the class today. But we want a public IP address for our instance. Then only we can test it, correct? So I'm going to select it and say enable. But by default, the subnet property says no public IP address. That is why it's called disable. Now I'll show you in the subnet properties where do you set that. But I'm going to make it enable. Click next. This is all our thing. Next, I'm going to call it as class 10 SRV001. Security groups. Did we create any security groups? The default VPC created one thing, but we need VPC security groups are living where? Security groups are within region or availability zone or where it is. Come on, guys. Security groups. Where is the reach of? Where do you create security groups?
For VPC.
Anywhere instance.
Security groups can be created only within a VPC. Okay. You cannot create security. A security group is only available within a VPC. So this VPC, our class 10 VPC, don't have any security group. It has some default. So we create a new security group. Let's call it as, you know, RDP-test. Okay. That's enough. RDP-ping-test. I'm going to add a ping also. ICMP. All right. And I'm going to save this. Review and launch. I don't want any key pair. I'm going to do that and launch it. So now I'm creating an instance and it is launching. If you go to the Ec2 Instances, you will see that the new instance is getting launched. You can see that the instance. First thing itself, if you look here, your instance got a public IP address because which subnet are we now? And you see what is the IP address it got. Tell me what is the IP. What is the subnet? No, we put, it is not 20, okay, we put 10, right? Everything we changed to 10, correct?
Yeah.
Don't look at that. So in this one, when you create an instance, it will get an IP address of what will be the IP address of this?
10.0.1.
1 dot something, correct? Look at what is our instance name, instance IP address.
91.
Yeah.
10.1.
And it says subnet ID. What is the subnet? That instance is in this subnet ID. So if you go here and copy that and go to the subnets, VPC, If you go to the subnets and put this subnet ID and search it, subnet 1, correct? That is a subnet 1. Now I told you about a setting, auto assign public IP address is no. You see that option?
Yeah.
That is why when you create a new instance, you see it disabled, right? Auto assign public by default a subnet. So when you create a subnet, where is that option? I forgot. Okay, hold on 1 second. I think we can change this. We can change this value. Let me just find out, okay? How do we change this? There is a way to change this option.
Under setting on top? No.
No, subnet actions. Modify auto assign IP settings. If I change this to enable, then by default it becomes public IP. By default it is disabled. Okay? You getting what I'm saying, guys? Auto assign IP address is thing. We will do that for subnet 5. Let's see that. So I'm going to go to subnet 5 and I'm going to do this option. I'm going to say enable auto IP address to public and I'm going to save it. So now auto assign public address is enabled for subnet 5. Okay? And now let's go and create another instance. Launch instance. My AMI. Next and next. VPC class 10 and I'm going to select subnet 5. You see here subnet setting becomes, default settings become what?
Enable.
Why is it enable? Because in the subnet I went and selected enable, correct? So do I need to do anything? In this one, when I launch this instance, it will automatically get a address.
Okay.
So I'm going to say class 10 test 88. I'm just putting a name for that server. And this time I'm going to pick the same RDP TESI. I created that VPC there. I can use the same thing, launch and launch instance. So I'm creating another instance now. Now let's go back and look at this instance now. The second instance is coming up. It got a public IP address. What is the IP address here? Private IP address. Okay, so you see that IP address, does it make any sense? 10.0.5.65? Is that a meaning, I mean, does it make any sense that IP address, do you think it will justify the way we did it? Accordingly, is it the correct IP address? Belongs to
Yes.
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 because we put it in subnet 5, that is why. So that is why I called it a subnet 5. When you look at this number, you know it is in subnet 5. You know, so this is actually subnet 5. If you that's a subnet ID, but here itself I know it is in subnet 5. But you can copy here and you go to the subnets. You cannot see subnets from here. You have to go to VPC. You will be able to see. So if you go to subnet 5, and you will see subnet 5. I think you guys got some idea now, correct? Some idea, but there is a lot more to learn, but we will come back and talk. I think at least you got some idea where it is, correct?
Yes, sir.
I see like 95% people are still in the class, so that is a good sign. That means, you know, you are getting a couple of people dropped. That's fine. They will hopefully pick it up. This is going to be a long video also, but you understand. So try it out. So at least you are getting some feel, okay, how to create. Now you know how to create a network, correct? We are slowly designing our network. So tomorrow we will delete this and we will make a complete plan, a big network with public subnet, private subnet, and then we're going to start building servers. This is something I was showing, not tomorrow, in the next class, no class tomorrow. We will do it on Thursday. So Thursday we will have a project. First we will design that. When I design that time, then I'm going to call it as public subnet, private subnet, application server subnet, we will create different type of subnets, and then we will start working on it. Okay. So we'll stop here, guys. Thank you very much.